Okay, so in this video, I'm going to talk a little bit about, let me try to fix these margins while I'm at it. I'm going to talk a little bit about what you do if, sorry, I'm distracted here. There we go. I want to talk a little bit about what you do if you're actually not given the angle that you want to find the sine or cosine, etc. of. So the last thing that I had you do is I had you look at like the sine of 30 degrees or the cosine of 150, and your job was to give me like the trig of actual angles, right? So like, for example, I asked you what the sine of 135 degrees was, and you looked on the unit circle and you were able to tell me that that was the square root of 2 over 2. Okay, what we're going to do now is we're actually going to do some work where you don't know the angle, but you have to find the trig ratios of that angle. And so the first thing is we're going to learn a Greek letter that we use a lot for angles, and it looks like this, and this is the Greek letter theta. And that's most often what we use for angles is we just use theta. So it's the Greek letter theta. And so here's how these usually work. So they want us to draw an angle that's in the first quadrant, but we're not given the measure of the angle. So we can't really just, sort of say, oh, this is 30 degrees and then go ahead and draw it. They're telling us, though, that the terminal side of the angle, so terminal side right here, that means that that's the end of the angle. So we know that when we draw an angle in standard position from a previous lesson that you did, that the initial side goes on the positive x-axis, so like this, and then the terminal side, it ends wherever you tell it to end. So what we're saying in this case is we want the terminal side to pass through the point 3, 4. So if I plot the point 3, 4, just like you would have done in like a pre-algebra class, I go over 3, I go up 4, and I go ahead and plot that point. And then what it's saying is draw the terminal side of the angle so that it passes through that point. It doesn't matter how long you draw these rays for the angle. It doesn't change the angle. So for example, if I drew my rays like this long and like this long, right? This angle in here, theta, is the same if I draw the rays shorter, right? So if I say, okay, I'm only going to draw it to there, and then I'm going to stop there, right? Instead of going all the way out here, it doesn't matter. The angle is still the same, okay? So I just drew the rays like arbitrarily in length, but this is the angle that it's creating right here, this little distance in here. So what I'm going to do is, if I want to find, and here I'll write theta in there, if I want to find all of the trig of that angle, so sine, cosine, and that says it down here, tangent, etc., what I have to do is make a triangle. So what I'm going to do is I'm going to go to where that ordered pair is, and I'm going to draw an altitude, which is a vertical line that creates a 90-degree angle with the x-axis. And what I've just created is a right triangle, okay? And so what I'm going to do is I'm going to kind of get this stuff out of the way, and I'm going to draw that right triangle bigger over here. So I'm just going to take this right triangle and just draw it larger over here. So I'm just going to kind of go like this, and then kind of do my best there. I always do that, like draw extra, so just cheat a little bit. Okay, so then I'm going to draw a right angle right there, and then I'm going to call this theta. Well, if this ordered pair right here is 3, 4, okay, then I know the distance from the origin, right, to the end here, so this distance right here, I know that that's 3, so I'm just going to copy it over here. And then same thing, the y-axis, that distance would be the y value, or 4. If I want to do SOHCAHTOA, right, which I think we talked about in a previous video, so sine, cosine, so opposite over hypotenuse, adjacent over hypotenuse, and tangent, TOA, then I'm missing a side of this triangle to be able to do that with, and that would be the hypotenuse. So to find the hypotenuse, you just do the Pythagorean theorem. So I would do 3 squared plus 4 squared is equal to, this is the hypotenuse, so you could call it h if you want. But since we're working with a unit circle, or basically like a circular angle system here, we typically call that r because it would stand for the radius of whatever circle we would draw in here. So we just usually write r squared. So if you just do the Pythagorean theorem, you get that 25 is equal to r squared, and you take the square root of both sides, and you get r equals 5. R is always positive because it's not directional. It stands for the radius of the circle. So even though the square root of 25 would be plus or minus 5, when you're finding the radius, or r, which is the hypotenuse, you always just say it's positive 5. So I'm going to take that over here and put that. Okay? Now, this next part is just really easy. It's just SOHCAHTOA. So if I want to find the sine of this, if I want to find the sine, what did I do? I want to find the sine of the angle, it's just going to be opposite over hypotenuse. The cosine of the angle is adjacent over hypotenuse. And the tangent of the angle is opposite over adjacent. And then if you want the reciprocals, all you have to do is flip the original. So this would be 5/4. This would be 5/3. And this would be 3/4. And so that's just another way to find all of the trig values of an angle if you're not given the angle. So what you'll be given is a point on the terminal side of the angle. So where the angle ends, you'll be given a point that it goes through. And then all you have to do is kind of draw it so that you have a right triangle. And then find the missing side of the right triangle, depending on what it is. And then just set up your SOHCAHTOA ratios. Okay? So I'll do another one with you. I thought I would. Oh, give me 1 second. I'll pause it and go get the other question. Okay, so that magically appeared on your screen. I want to show you that angles can be in other quadrants as well. So this one says that the angle terminates, goes through the point -3, -9. So I'm going to start the angle in the on the positive x-axis as normal. And then I'm going to plot the point -3, -9. And then I'm going to draw my terminal ray through that point. And now that's a big angle, right? It terminates in the third quadrant, so it's greater than 180, right? Because this is 180 degrees, and it's less than 270. We don't even really need to know that. I'm just trying to show you that that's the angle that we're dealing with now. Well, you only have to draw the altitude to the positive x-axis. Just make sure you always go to the x-axis or you'll draw your triangle wrong. Angles are always measured with respect to the x-axis. And so this is a right triangle. So I'm going from the terminal point, and I went back to the x-axis, drew a right triangle, and then this guy in here, this angle that it makes with the x-axis is theta. Okay? And I know that this distance from the origin to here is 3, and then this distance down to here is 9. Now, I would call them negative so that when you do the trig, the SOHCAHTOA, you get the signs right, because you'll miss them, I think, if you just call them 3 and 9. Now, when we do the Pythagorean theorem, you can put them in as negatives if you want, but remember, when you square a negative, you get a positive anyway, so that part doesn't really matter. Just make sure you do get positives here. So -3 squared is 9. And then -9 squared is 81. And so we get that r squared is 90. And if we take the square root of 90, we would get, so 9 times 10, right? So 3 square roots of 10 is equal to the radius, okay? Or the hypotenuse of the triangle, if you want to think of it that way. So I'm gonna erase a couple of things so I can just make this triangle bigger, so that we can just do SOHCAHTOA with it. So let me do that real fast. So here's that triangle that I drew, and I'm just literally copying stuff over so that it's easier to see. So -3, -9, and don't forget the radius / hypotenuse is always positive. Okay, so now I'm just going to do SOHCAHTOA for everything. Pause the video if you need any of this right now, because I'm going to erase it so that I have more room. And actually, I think I have a way of maybe erasing that more quickly so that we're not, oh, nope. You're like, learn how to use this. Okay, there we go. Okay. All right, so I'm going to do the sine of the angle. Well, the sine is going to be the opposite. So here's -9. And then over the hypotenuse. And the hypotenuse is 3√10. So 3 square roots of 10. We have to simplify this. So first, 3 goes into 9. So this would be -3 over the square root of 10. You're not allowed to have radicals in your denominator, so you have to rationalize it. And when you rationalize, you just multiply by the radical. So if we take -3 times the square root of 10, that's -3 square roots of 10. And then the square root of 10 times the square root of 10 is the square root of 100, which is 10. So here's the sine of the angle. To get the cosecant, I'm going to do that one next. You want to flip the sine value, but don't flip the rationalized version, because if you flip something that's rationalized, it's going to become unrationalized, and then you'll have to rationalize it again. All you have to do to make this easier is go back to the unrationalized form and flip that. So if I flip this, I get -√10 over 3. Like I said, you could flip that, but then you'd have to rationalize it again. You'd get the same answer if you rationalized it and simplified it correctly, but it's much easier to go back and flip something that's unrationalized, and then it immediately becomes rationalized. Okay, so let's do the cosine. The cosine is going to be adjacent over the hypotenuse. So adjacent over hypotenuse. That would simplify to -1 over the square root of 10. And if you rationalize it, you get -√10 over 10. We'll get the secant right now because it's pretty easy. I'm going to flip that version, and I just get -√10 over 1, which is just -√10. If I want the tangent of the angle, that's going to be opposite over adjacent. So -9 over -3, which is just 3. And then the cotangent is just the reciprocal of that. So the reciprocal of 3 is 1/3. Okay? So we spent a good deal of time figuring out how to find the trig of angles that we don't know, and we just drew them and then found the sine, cosine, tangent, secant, cosecant, and cotangent of all of those angles. So I'll give you a couple of practice problems so that you can try those. But, you know, and the other thing is, you don't have to draw it on a coordinate plane. Like, you don't have to plot every single point. So I'll actually show you what we ended up doing after that. So, like, we started just drawing. So, like, I'll show you this one. We started just, like, drawing every triangle without actually plotting the point. You just have to know what quadrant you're in. And I'll explain to you why you have to know what quadrant you're in as well. So you learned in like pre-algebra or whatever, when you have a coordinate plane, right? And this is your x-axis and this is your y-axis. Both coordinates are positive in the first quadrant. In the second quadrant, your x's are negative, but your y's are positive. In the third quadrant, both coordinates are negative. And then in the fourth quadrant, your x's are positive and your y's are negative. That actually carries over to the values of the trig functions. So let me show you that. So like, let's say I draw an angle, and I'm just going to go ahead and draw it in the first quadrant, okay? And I'm going to call this side x. Just going to make it bigger so you can see. And I'm going to call, and actually let me move this over a little bit. So I'm going to call this side x because that's the x-axis. I'm going to call this side of the triangle y. And then I'm going to call the hypotenuse r because if we superimposed a circle on there, it would be the radius of the circle. And I'm going to just call this theta. And so if you SOHCAHTOA this theta with respect to x, y, and r, you get that the sine of theta is opposite over hypotenuse. The cosine of theta is adjacent over hypotenuse. And the tangent of theta is opposite over adjacent. So, and then you can do the reciprocals too. And all you have to do is like flip this stuff. I tell them not to memorize the reciprocals because if you want to get a reciprocal, I would just find the original and then flip that. But there's the reciprocals. So check this out. In the first quadrant, if your x and y are both positive and r is always positive, if you put positives everywhere here, then all of your trig functions are positive in the first quadrant. So if your angle is in the first quadrant, sine, cosine, tangent, secant, cosecant, cotangent are all positive. If your angle terminates in the second quadrant, okay, if you make every x here negative, so that x, that one, and that one, so this would be a negative over a positive. This would be a positive over a negative. This would be a positive over a negative. And this would be a negative over a positive. These four trig functions right here in the second quadrant are negative. So if you have an angle in the second quadrant, your cosine, secant, tangent, and cotangent of that angle are all negative. So the only trig functions that are positive in the second quadrant are sine and its reciprocal cosecant. So we just say sine and then we assume cosecant. So I'm going to write that the sine is positive in this quadrant. Now, if you go back over here and you make your x's and your y's negative. So if we went negative, 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 negative. A negative over a positive is going to be a negative. So sine's going to be negative, cosecant's going to be negative, cosine's going to be negative, secant's going to be negative. But if you divide two negatives, you get a positive. So in the third quadrant, it's tangent. Every time I hit that button, it's tangent that's positive in the third quadrant. And don't forget, its reciprocal follows it. And then lastly, if we do the same thing with all the negatives, in the fourth quadrant, the y coordinate is negative. So if you make all these y's negative, so this would be a negative, this would be a negative, this would be a negative, that would be a negative, and this would be a negative. So if you look, it's your cosine that's positive in the fourth quadrant. So in the fourth quadrant, cosine is positive. So if you look at the first letters of all of these, you get A, S, T, C. And we made up a sentence. I mean, this sentence was the same sentence when I was in high school. And you go A, S, T, C. And we say all students, just like kind of memorize a little sentence to remember the letters, take calculus. And what that does is it tells you which trig function is positive in which quadrant. So that's just another way of doing it. So that's a good thing to know. So if I said, hey, I have an angle in quadrant 3, what trig functions are positive? Well, it would be tangent and its reciprocal cotangent. So like I was saying, if you're going to do one of these problems, you don't have to draw the angle every single time. Like you don't have to plot the point. So, whoa, that was unintended. There it is. So if I had to do this problem and I wanted to find the exact value of the 6 trig functions of an angle that passes through the point 5, 3, I know that 5, 3, since both coordinates are positive, is in quadrant 1. And so I could just be like, okay, I have a triangle, right? And I don't have to do like a perfect job of drawing it, right? Which is good. I know the x coordinate is 5 and the y coordinate is 3, and then this is theta, right? So then I could do the Pythagorean theorem and find the hypotenuse. So 9 plus 25 equals r squared. R is the square root of 34, and so this is root 34. Since I'm in quadrant 1, all of my trig functions are going to be positive, and then you would just do SOHCAHTOA here. Okay? So I'm going to give you a little assignment to try on this, and then I'll try to make you another video about the trig identities that we're working with right now. So yeah, give this a shot. Don't spend a ton of time on it because this isn't something that, well, yeah, actually, never mind. I lied. Kind of make sure that you understand this. And then I'll send you another short video on a bit of a shortcut on this. And let me see how much time I have left. Actually, okay, I'm like arguing with myself on this video. I'm actually going to show you the shortcut real fast. So if we go back to here, this is actually the shortcut so that you don't have to draw the triangle every single time. So I'm actually going to grab this. If you don't understand where I got these fractions, I just drew a triangle, called it X, Y, and R, because this is the X-axis, this is the Y-axis, and then I just did SOHCAHTOA all around it, okay? And these actually make up what's called the XYR method, and I want to make sure that you do actually understand that, because the thing that we did in class today actually kind of assumes that you know that. Okay, so watch this. So I'll give you an example here. So we'll say, suppose an angle past the terminal side of an angle passes through the point, we'll do 5, negative 12. And I want you to find the sine of theta, the cosine of theta, and the tangent of theta, and we'll just do the reciprocals for good measure. So I'm not going to draw this, okay? What I'm going to do is I'm going to make a table, because in an ordered pair, I know this is x and this is y, okay? Well, if I know that x is 5 and I know that y is negative 12, I need to figure out what r is. So I would do the Pythagorean theorem. This is what's called a Pythagorean triple. And so I told the students that there are 4 Pythagorean triples that they should know. I'll write those down at the end of this video for you. But for right now, if you did the Pythagorean theorem, r would be 13. Okay? And again, I know that because 5, 12, 13 is a Pythagorean triple. And if you didn't know that, you would just do the Pythagorean theorem. But like I said, there's like 4 triples I told the kids to memorize, and I'll write those down for you. But like, see, now I didn't have to draw anything. If I know that sine is the y coordinate over r, I can just go down here to my table and say that this is negative 12 thirteenths. I can flip it to get cosecant. It doesn't matter where you put the negative. Cosine is 5 thirteenths because it's x over r. Secant is the reciprocal of that, so 13 fifths. And then tangent is y over x, so negative 12 over 5. And then cotangent is its reciprocal. Okay, so that's a way easier way of doing it, so you don't have to draw the picture every time, but you do have to memorize where the x's and y's are. So maybe use that on the assignment that I give you. Here are the Pythagorean triples that you should know. These are obviously not the only ones that exist, but these are the kind of most popular. So if you know two of the three numbers, you don't have to do any math to get the third one. So the Pythagorean triples are 3, 4, 5. Again, not the only ones, but the most popular ones. 5, 12, 13, 8, 15, 17, and 7, 24, 25. So those are the Pythagorean triples that I would memorize. And then I would also memorize this setup. Okay? So I'll send you a couple of practice problems to do to make sure that you understand. It's really important that you understand the XYR method because, like I said, we're actually using that right now. So yeah, email me with any questions.